Hmm. You may be wondering, what is this object in front of us? For some, it looks like an ice cream cone, but for others, like me, a physician, that is a crush barrier. Yes, it may sound weird, but it is a solid crash barrier that actually worked on a tested set of car from Pascal. So, welcome to my project, the Perceur, or the crash barrier. For our background problem, this is an AP Physics 1 project. This project leads us to ideate using design thinking and applying the right knowledge and skills to create a sustainable crash barrier that can mitigate the force of a crash. So the project mission, as I have talked before, is creating a solid and effective mock-up crash barrier design with the Pascal set. So what is our project focus question? As this is a project with from me, Axel, and my partner Trey, our focus question would be how can we apply the scientific method alongside design thinking into creating a sustainable future vehicle? And for the big question, by applying the we believe that by applying that skill set and to leadership and values, we're able to transform the current standards for cars and their crash barriers into the proper vision that we have. For our hypothesis, we believe that if we can measure the momentum to velocity and mass, we could determine whether the crash barrier successfully reduced the impact force of the car. And for the methods, as stated before, as we are the AP Physics 1 student, we are tasked to make and create this project to ideation and scientific methods alongside design thinking to research, create constructing hypothesis, and then testing our prototype in a set of Pascal and state whether the prototype succeed or no. And if it does not succeed, we would troubleshoot the procedure and retrace our step again. So what is the design thinking? A design thinking is a non-linear process. It's a process where we think into the people who are going to use the product. For instance, as we are talking about a crash barrier, we should be thinking in the minds of the driver. We should empathize, we should define, we should ideate, prototype, and we test. And why should we think from the perspective of the people who are going to use this design? Because we want to we as a researcher, we got to make things that are feasible, and we got to make things that, in other words, in simple words, make sense and fits to people who are going to use it. For instance, one of the one of a failed product that may be caused by a poor design thinking would be an wi-fi operated juicer. Maybe it sounds cool, a Wi-Fi operated juicer. However, as someone who likes to make juices, do we actually need a Wi-Fi based juicer? Does it actually make sense for the user? Would you like to have and pay such huge amount of money just to juice juices from your room? Well, of course, no. That's why it's a failed product. And that's why in this project, me and my partner Trey, we take to the and we dwell to the mind of the drivers. We dwell to the user of the cars, and we take what is actually fitting for this design. What does this design need in order to succeed? That is why we think, then we define, then we ideate the product, then we create a prototype, and we test it to a Pascal set. So, what is the test? What is a Pascal set? A Pascal set is a near equilibrium testing set. As we know in physics, an equilibrium is a concept where there are no um, extraterrestrial forces working on. So, in order to find the best result for the independent and the dependent variable, because when we are testing something, sometimes we gotta put aside the unnecessary forces out, and we need to have the things that actually matters the most, the forces we're actually testing about. And moving on, we have the scientific method as an ongoing process. This is very similar to the design thinking, but still, we're required to explain about this one. First, we gotta make observations. Then we gotta think of interesting questions. Then we formulate hypotheses, as we have done. And we develop testable predictions. And we gather data to test the predictions. And we refine, alter, expand, or reject the hypothesis. If we reject the hypothesis, then we go back to develop testable predictions. We gather the data again until we finally find the answers to our hypothesis and prove that hypothesis to be correct. Then after that, we're gonna develop general theories, and then we're going to go back to making observation, and it will go again and again and again and again, as the scientific method is an ongoing process. And for the third part, we also should consider recycle, reduce, and reuse and reduce. 3R. We are tasked to um, emphasize the importance of recycling and green. That's why we have used several recycled materials, and in our Pascar, we have used chopsticks, used chopsticks, ice cream chopsticks. Let's just consider that as a used ice cream chopstick. And we also used sponge, and we used tapes. And those things are usually found in the recycling plant at a larger scale. For instance, we can for the sponge we can use used foam. There are plenty of those used foam in recycling plants. And for the chopstick, we can use used woods. And for the tapes, we can find lots of things in the recycling material to cover up, such as ties, such as strings, and etc. However, still, although we are focused and tasked to use the recycle, use, and reduce to use recycled materials, sometimes we still need to also incorporate new materials into the product, because we cannot have it 100% recycled, because sometimes we need to incorporate things into it. There are things that we just can't recycle, and we can't find it in the recycling place, because if they are in the recycling plant or in the trash, it is most likely that they are not useful anymore. Just like tapes, we cannot recycle tapes. And we're gonna go to the independent variable. We're talking about sponge thickness. In this, as in the silk coat region, we see the thickness of the sponge. We have the green one and the pink one. The green one is a thicker sponge compared to the pink one, because we have a two test where we use the pink one only and the pink one and the green one too, and that is the measurement of the sponge thickness that became our independent variable in this test, because it would affect the amount of the results of our Pascal crash simulation. And we have the dependent variable. We have the velocity of the car before impact. We can see in this table where the first prototype have the average velocity of 0.21 meter per second, while the second prototype have the average velocity of 0.22 meter per second, 283 meter per second. And please be noted that we're gonna go back to the last one, that the sponges, the two sponges, the thicker sponge is in the second prototype, and the less and the less thicker sponge is in the first prototype. And we can see that we have also the displacement, which are both the same, 49 centimeters or 0.49 meters, and the weight of the first prototype and the second prototype differs a bit, which is 18 grams and 20 grams. So, what is our result conclusion, and how do we actually find the result? What actually, what made us able to conclude the hypothesis and conclude an answer to the hypothesis to this result? We can see that using this formula, momentum equals to mass times velocity, we can actually determine that this prototype actually reduced the amount of momentum that is exerted. For instance, let's take a calculator out here. I'm going to take this calculator in my laptop right now, and I'm going to calculate. The first one would be 0.2601 multiplied by 0.01. That would be a momentum of 0.0004. While the other one, let me take another calculator, we can see that, hold on a second, we would have 0.2283 multiplied by 0.02. Yes, we have a very, very slight reduction in the impact force, the momentum, and because we have, uh, I think you cannot see it on the screen, but I have it on my calculator right here. We have, this is the first prototype, and this the second prototype, my bad, would be the 0.2283 meter per second and 20 grams, while this both result, the first prototype and the second prototype have a slight 2% difference in their momentum reduction. So, although this may sound like a small reduction, but it's still a reduction, and it concludes that our hypothesis is true. That if we change the size of the independent variable, which is a sponge, the thickness of the sponge, we can absolutely find the reduction of the force that is exerted to the momentum. And that is all for my presentation. This is our project from Axel and Trey. And thank you very much for listening about our design and thinking. And also, uh, I forgot one more thing, that the design and thinking process is very much done in this project. And we believe that it is very successful. And we have dwelled into the minds of the driver, and we have also prioritized the safety of the driver. And that's all. Concluding again, thank you once again, and I'll see you next time if I ever meet a physics project again, which I doubt. Thank you.